Well, now let's work on solving base E equations. And using the natural base E and the natural log really kind of helps make solving logarithmic and exponential equations easier because the ln of E equals 1. So when we take the log of E, that equals 1. So let's look here. We got 3 times E raised to the 4x minus 12 equals 27. Well, we're just going to solve this like we normally would, at least here for the moment. We're going to add 12 to both sides. So now we got 3 times E to the 4x equals 27. And let's divide both sides by 3. And we got E to the 4x equals 9. And now we're going to take the natural log, ln E raised to the 4x equals ln 9. And that leaves us with 4x equals ln 9 because ln and E equals 1. And now we can divide both sides by 4. And here we are, we got ln of 9 over 4 equals x. Now, ln 9 over 4 divided by 4 is in fact a number. And in a few minutes after we take a look at the next example, and both of these examples happen to be located on page 503 in your textbook, example 4, we're going to get on the calculator just briefly and put these expressions in. So kind of make note of this. But once I put it in the calculator, I'm going to find that x is equal to, or approximately equal to, and I think we're being asked to round this to the nearest 10,000th, 0.5493. Okay? Make sure you ask questions. We want to be persistent. We want to practice, use patience, and persevere. Let's look at one more, and then we'll get to the calculator. But jot that down, x equals ln of 9 over 4. All right, so here we got a second equation. It's 4 times e raised to the power of x plus 8 equals 17. Well, let's start by subtracting 8 from both sides. Let's see, 17 minus 8 is 9. And we're going to divide both sides by 4. So we got e to the x equals 9 over 4. I'm going to just leave it in fraction form. It's just as easy to do that. Let's take the log of both sides, taking the natural log of both sides. And ln of e is 1, so I'm left with x equals ln of 9 over 4. Now, once again, that also is a number. Oh, that's negative x. Excuse me. I just wrote that problem down wrong when I typed it in. Negative x, negative x, negative. So I got negative x equals ln of 9 over 4. So I'm going to divide both sides of this by negative 1, and that gives me x equals negative ln 9 over 4. And x then is going to equal negative 0.8109 rounded to the nearest 10,000th. And again, make note of this because we're going to put this in the calculator, negative ln of 9 over 4. And let's make sure it does in fact equal negative 0.8109. So hold on just a moment. We're going to move to the calculator, enter a couple of expressions. And I'm just doing that just to make sure that we've got a little bit of demonstration as to how we may want to enter these. All right, well, we've moved over here to the calculator, and I just want to enter these just to make sure that we can see and demonstrate, make sure we all know how we're going to enter when we're finding the natural log, solving an equation with base e or natural logarithms. And if you recall on that example 4a, we got to the point where x is equal to ln 9 over 4, which computed out to be rounded to the nearest 10,000th, 0.5493. So I got my calculator up, and I'm going to hit ln, and it's going to bring that up in parentheses, and I'm going to put a 9, and I'm going to close the parentheses, and then I'm going to divide by 4. And once I do, we can see that when I round that to the nearest 10,000th, that's 0.5493. Now let's move to the next one, where we had, we got down to, this was in 4b, we got down to x is equal the negative natural log of 9 over 4. So to solve that, I want to first hit the negative, not the subtraction, hit the negative button, and then hit ln. It brings up the parentheses, and I'm just going to simply put 9 over 4 and close the parentheses and hit enter, and I'm expecting to get negative 0.8109. Let's see. Yes, negative 0.8109. All right, just a little brief demonstration using the calculator to finish the computation involving natural logs.